Welcome, everyone. Thank you. All right, thank you. Yeah, my name is Nic Wortel. I'm an independent PHP and DevOps consultant. I help various companies with their PHP and DevOps to increase their quality of their software, but also their security. Besides of that, I am one of the organizers of the PHP Amersfoort meetup group in Amersfoort. If you want any stickers, come after the talk, and we have some nice stickers. And last but not least, I work as a reservist in the Dutch Army. So that's something completely different than IT, but I work there part-time, and it's a nice combination to do some different things. So this is actually me during a leadership course last year in the mountains of Austria. So yeah, that's a nice change of scenery once in a while. But right now I'm going to talk about security. That's what you all came for, right? So security in PHP applications, and the first question is always, yeah, why does it bother me? Am I at risk? So I want to start with a small story that I encountered some years ago. It was a freelance client that I was working for, and in my first week there, I was still getting used to the project and finding my way through the code. And I found a small file that contained some credentials for the database and for AWS and some other stuff. And I was thinking like, that shouldn't be committed in the source code, that should not be in the Git repository, but okay. But then I realized, hey, is this file in the document root of the web application? So if I type in this URL in my browser, do I see this file and do I see these credentials? And turns out I did. So there was a file that was just publicly accessible. You had, of course, to guess the URL, but it was not super difficult to guess it. And yeah, for some reason, for many years, nobody really noticed the fact that this file was just publicly accessible. It was not blacklisted or in some firewall that you could not access it. Everybody could just go to this URL and find these credentials. And they actually gave you access to AWS S3 buckets with some confidential information. Yeah, so that was for me like, yeah, that's one example of the fact that, yeah, sometimes security can be overlooked. And usually in our day-to-day work, we're not always doing everything with security in our mind. As a consultant, nowadays I also do sometimes security audits for clients. And I actually, for this talk, I gathered some statistics to show you some insights about what I have seen with my clients and their applications. And one of the things was that 82% of the applications that I audited turned out to contain some kind of security vulnerability. So why does it matter? What happens if we have a security vulnerability? Well, obviously, yeah, it can have some impact on the business. Like, it can hurt our reputation with clients. It can disrupt our operation, especially if data is being deleted or if something is damaged. If we lose our reputation with our clients, it can also mean that they go away to the competitor, so we can lose revenue. And of course, we have also GDPR and other regulations that can give us fines if we don't treat security how it should be. What's also important to realize is that the majority of cyber attacks are not targeted. It does not mean that you have to be a high-value target and that attackers are specifically coming for you. They're just using automation to go all over the internet and see just whatever applications are vulnerable or have something open. I think also an important thing to note is especially, AI right now is a big topic, and of course I need to somehow put something about AI in my talk. So what is going to be the impact of the developments with AI currently going on? What impact is it going to have on the security of our code? How many of you sometimes use AI to generate code like Copilot or other tools? That's quite a lot of hands. Actually, a survey by GitHub turned out that 92% of developers are using sometimes AI to generate their code. Well, the problem is that this code is not always secure because these AI tools, they are trained on the code that is available, and if the code they trained on is not secure, then the output is also not necessarily secure. So another study turned out that 30% of the code snippets generated by Copilot actually contain security vulnerabilities. Actually, other studies came with even higher numbers, up to almost like 70%, so it's a little bit different depending on which study you look at. But the point is that the code generated by AI is not necessarily secure. And I think this is, especially in the coming years, going to be a bigger problem, because it means that more vulnerabilities will end up in our code bases. Yeah, so to sum up, yes, definitely your application could also be at risk. And this is not something that you can ignore just because you are a small company and not a high-value target. So this talk, of course, it's going to be about static analysis and how it meets security. But first of all, let's discuss what is static analysis in the first place. Anybody who here uses static analysis tools to check their code? Nice. How many of you use static analysis to check your code for security vulnerabilities? A little bit less hands. Okay. Well, hopefully after this talk, it will be more hands. Yeah. So first of all, what is it? So the static analysis is the automated analysis of source code without actually executing it, right? Technically, you could say that if I'm reviewing code by manually, then it's also static analysis, but for now I focus on the automation. So what for can we use static analysis? So for those people who raise their hands, maybe the reason why you're using it is within this list. So detecting type errors, like when we are passing an integer to something that should expect a string, or other potential bugs, or issues with the code quality, or enforcing coding standards that we have, etc. Yeah, some common tools that we use within PHP are tools like PHP-Stan, Psalm, but also things like Mess Detector, Code Sniffer, Coding Standards Fixer, DepTrack, Rector, etc. There's a lot more. I think there's Damien, I don't know if he's in the room here, but he has a big GitHub repo with a long list of static analysis tools. But these are, I think, the most commonly used ones. Yeah, so what are the benefits of using static analysis for these kinds of purposes? So we get fast feedback because a static analysis tool can usually run in a matter of seconds or maybe minutes. It gives you consistent results, more consistent than when we are manually reviewing it in a pull request. It does not require writing a lot of tests, like unit testing does. We need to actually invest time into writing the tests. The static analysis tools don't need this. We just configure the tool, run it, and that's it. And because we don't need to write tests for it to work, it covers the entire code base. So we do not run into the fact that we only cover some part of the code base with tests, because the static analysis tools will cover the entire code base. Yeah, but so far, so good so far. But this talk is going to be about using it for testing our application, specifically about security. And the same benefits that I mentioned before also apply when we use static analysis to test security issues, because again, it gives us fast feedback. We don't have to write specific tests for it, and it covers the entire code base. So that makes static analysis a useful tool that can help us find security vulnerabilities consistently and quickly. So let's see some examples of tools which I use personally when I, for example, audit projects of clients. So let's see what kind of tools we can use. First, actually, I want to start with code quality. And maybe what I'm going to discuss now you're already using, but I want to specifically mention it because code quality is a good way to prevent us from introducing the security vulnerabilities in the first place. Yeah, because bad code quality, which means code that is difficult to read, makes it easier to introduce vulnerabilities and makes it more difficult to spot them if we are reviewing each other's code. If we have nice code quality, then it's easier to spot that something's going wrong. But if the code is really difficult to read, the security issue can go unnoticed for a long time. So as I mentioned before, the statistics that I gathered from these audits that I did for my clients, actually all of the projects that I audited had some kind of code quality issues inside them. And these are not, as I mentioned, these are not vulnerabilities by themselves. You cannot hack an application because there's some code duplication going on. But those issues make it more easy for real vulnerabilities to get into the project. So things like duplication, code that has been commented out, but nobody really knows like why is it still there, why hasn't it been committed, and why hasn't it just been removed. Things like suppressing errors or catching exceptions without properly handling them, high code complexity, and things like to-do comments like, hey, something's wrong here, we still need to fix it, but we didn't have time for it. Yeah, and there's a bunch of useful PHP static analysis tools which you may or may not already be using for these kind of issues. So for code complexity, like very big files or very complex functions, we have PHP mess detector. We have PHP copy-paste detector for detecting code duplication. Code sniffer can catch a lot of different things for the code quality issues. And tools like PHP Stan and Psalm can also detect even dead code or code that is not reachable and will never be executed. So the main takeaway here is before you dive into all the other security stuff, make sure that you also pay attention to the code quality to reduce the chance of the vulnerabilities to getting into your code in the first place. All right, vulnerable dependencies. Who uses open source software dependencies in their applications? Everybody, right? Because we're at PHP conference, PHP is open source itself. But we also have things like composer dependencies, etc. Again, some statistics, like from the applications I audited, like 73% of these applications used composer packages, specific versions that contained a vulnerability. And this does not always mean that the application is directly vulnerable, because not all the time do you actually use the functionality in that package that is vulnerable. But it does at least mean that these projects do not actively monitor for vulnerabilities in the packages that they are using. At the same time, 55% of these applications used packages that were unmaintained or abandoned, meaning they do not necessarily contain known vulnerabilities, but at the same time, if a vulnerability exists, it may not be found, or if it's found, it may not be fixed, because the project is not maintained anymore. This statistic is not from my own research, but I pulled it from packages.org. So in February of this year, 15% of the PHP installations were outdated versions of PHP that no longer receive security fixes. Currently, 8.1, 8.2 receive security support, and 8.0 and older do not. Why is this relevant? Because, I pulled the last patch version of every unmaintained PHP version, and as you can see, the further back you go, the more known vulnerabilities are in these PHP versions that are just not being fixed anymore. And quite a bunch of these are actually exploitable, and you can probably find online how to exploit them and how to easily attack applications that still run on an outdated PHP version. So for our composer dependencies, we can use actually a command that is in Composer itself. Who knows of the composer audit command? Good, that's good news. Yeah, so since Composer 2.4, I believe, there's a new command in Composer that just checks all the installed versions of your dependencies and checks if there's any known vulnerabilities for those versions. At the same time, Composer will also report if you use any packages that are marked as abandoned. So if someone used to maintain a Composer package, but they decide not to maintain it anymore for whatever reason, they can mark it as abandoned, and this signals you that, hey, nobody's maintaining this anymore, and if a vulnerability is found in here, there's a good chance that it will not be fixed for me, so I will be vulnerable. Doing this command, running it by hand is useful to get some insight, but it means that you only get notified when you run this command. So there's also some external services. Private packages is a paid service. I think GitHub Dependabot is included for most GitHub organizations. But they actually give you a real-time notification as soon as a new vulnerability is found. So if you check Composer audit only once per month, you can be vulnerable for almost a month. And with these services, you get faster feedback. But as I mentioned, it's not just about the Composer dependencies. We also need to keep in mind OS packages, PHP itself, etc. So if you are using Docker containers and you're building your own Docker images, it can be very useful to use also a scanning tool that actually scans the Docker image. So you know not just about vulnerable Composer dependencies, but also about other vulnerabilities. And you can use a tool for this, such as Trivy or Sneak, or there's probably more options for this. Anybody uses this? Okay. Yeah, so those are not PHP-specific tools, so they can detect actually vulnerabilities in a bunch of package managers, but also in the Docker image itself. Yeah, so what's the most important thing to take away from vulnerable dependencies is the fact, okay, make sure that we check regularly if we have any vulnerabilities in the dependencies that we use. All right, the next point is a little bit coming back to the story that I started with about committing secrets in our Git repositories. There was a bigger problem there. It was the fact that the secret is also publicly visible, but still the fact remains that we don't really want to store this kind of secrets in our Git repo. We want to use some other kind of secret handling process to deal with those and to make it secure. So there also are some tools available that can help us to actually scan our Git repo to see if there's any strings found in the repository that match certain patterns. For example, an AWS key follows a certain pattern. And these tools, they just can scan your code and detect these. The first two, Trivy and Sneak, you can just run from the command line. The other two, they run in your GitHub or GitLab. And in some cases, they can even invalidate the secret. So if you commit an AWS key, the AWS key automatically gets invalidated and it will not be able to be abused anymore. This is not really PHP specific, of course, but I still wanted to mention it because, yeah, we also deal with secrets and it's good to secure those. Security misconfiguration. We obviously write a lot of code, but also configuration. And there's, again, a few tools available that can help us to scan this configuration and give us some feedback on those. One more statistic. So almost 90% of the Docker files in the applications that I audited did not follow the best practices of Docker regarding security. This does not make them immediately hackable and completely vulnerable, but if there is some other leak or some other vulnerability, it makes the impact bigger because the attacker can escalate and go further. Here's an example from Trivy. I'm not sure about Sneak, but I have a feeling that they also cover something like this. But using Trivy on the command line, I can just scan my Docker file, and it will check for all these best practices and will give me feedback. In this case, I used a PHP base image, but I just used the default root user, and that is more privileged than necessary, so that can be used by an attacker to escalate and sometimes even escape the container and get into the host machine. So the recommendation is to not use the root user, but define our own user which does not have the same permissions, and only the permissions that it needs. But also the configuration for PHP itself. This is a tool called Iniscan. It's a little bit outdated. I had a little bit of difficulty to get it running, but once you run it in your server, it will scan the configuration of PHP, defined in the php.ini, and it will give you, again, feedback like, hey, which of these configuration settings are not secure or could be better. All right, using untrusted user input, and this is a very interesting one. So in this category, I'm going to actually combine a few different vulnerabilities like SQL injection, OS injection, a lot of different things where we rely on user input without checking that it's secure. In 80% of these applications that I audited, I found some kind of vulnerability in this category. So a few of the things I found were cross-site scripting, header injection, where user input ends up in an HTTP header, the unserialization of user data that can also be abused. One application, it was possible to, it was deleting a file based on user input, and someone could change the input to delete a file that was not supposed to be deleted. And server-side request forgery, where the server is being tricked into making an HTTP request to an unsafe location. So how can we detect this kind of stuff, these kind of vulnerabilities? And this is what is called taint analysis. And there's a few different options for this. There was an RFC for PHP that was rejected. But there's also static analysis tools that can do this for us. So what it's about is we actually look for what are the taint sources. So where is this untrusted data coming from? So like the query string parameters, the post body, these kind of variables. And what are taint sinks? So for instance, a SQL query or the HTML output. And if data from a taint source can be traced to end up in one of the taint sinks, it means that our application is insecure and is vulnerable for this kind of stuff. Assuming that we don't filter the data in between or that we sanitize it. So there's some tools available for this. One of them, and I'm not listing all of them, I'm just picking out two options here. So one of them is SamGrab, which is a tool not specifically for PHP, but for many languages. And we have Psalm. And Psalm is actually one of the two popular static analysis tools in PHP. And it also supports this taint analysis. To be honest, I've always been a big user and a big fan of PHP Stan, until I found out that Psalm contains this feature and PHP Stan does not. So nowadays I actually use both in my applications, and Psalm specifically for the taint analysis. So comparing them, as I mentioned, SamGrab supports many different languages, not just PHP. It has an open source version and a pro paid version. And the open source version is a little bit more limited than the pro version. So the open source version only supports analyzing one file. So that's a little bit limited, especially in more complex applications where many classes and files work together and the data flows from one file to the other file. But on the other hand, it also has some additional rules to detect not just the injection vulnerabilities, but also other kind of security vulnerabilities. On the other hand, we have Psalm. Psalm, as you may know it, it's just the regular static analysis tool. It checks the type safety and the potential bugs, etc. But it has a specific mode that you can trigger with a flag on the command line, and it will actually do a taint analysis to check if these kind of vulnerabilities exist. In comparison to SamGrab, it actually supports more complicated flows between different files and different classes, and it can follow the whole data flow without a problem. If you're using some kind of framework or specific libraries, such as Symfony, Laravel, or Doctrine, or whatever, there's actually plugins available for Psalm that can help Psalm to understand your application better. So that works quite well as well. So actually, Psalm has actually become my favorite for the taint analysis, and I've had good results finding this kind of injection style vulnerabilities, which other tools would not be able to detect. Yeah, I'm not saying you should only use Psalm or you should never use SamGrep. Again, I would advise to try them both and see what works best in your situation. But Psalm is definitely my favorite. So how can we implement these kind of tools in our development workflow? Because that's an important thing, because if we don't implement it, then yeah, it's useless. So first of all, you can do as I do when I do a security audit, is you can do just a manual one-time scan. I just go on the command line, I run these tools, I need to tweak maybe a little bit the configuration to get it working, but then I have it working and it gives me some information about the project. But of course, we want to do it more regularly, but because of one time using it is not as useful. So the better way is to actually use it in our CI/CD pipeline, and that actually makes sure that we catch these problems before they end up in production. In some cases, it can also be useful to do it on a schedule, not just when we push a new commit. For example, if we're checking for security vulnerabilities with Composer audit, but if we're not making a commit to the project in 3 weeks, then for 3 weeks we don't get feedback. And if during that time a new vulnerability is discovered, then we only find out 3 weeks later when we make a new commit, and it will be annoying because the commit is about something else, and now I suddenly need to deal with this, and in the meantime we have been vulnerable without knowing it. So it can make sense to have some kind of schedule. Depending on your threat model, it can be every day or maybe every week or whatever. But especially for projects that we don't actively develop, to have a schedule to make sure that we get this information as soon as possible. I also want to point out I've had good results with these tools, but also, as anything, it's not a silver bullet. So don't rely only on static analysis and forget about everything else. So keep using our automated tests to do tests for more specific things in our domain logic to make it secure, because static analysis will not be able to catch that. Also, keep doing your manual code reviews and keep having an eye on security in those, because, again, static analysis will not be able to discover everything, and some things are only seen manually. And it can make sense to do an external audit to go a little bit more deeper in the security and also check the things that can only be discovered when actually executing the code. So to wrap up, keep in mind your application too can be at risk. Static analysis is a nice and fast and consistent way to catch certain kinds of security vulnerabilities. Think about the code quality and make sure that your code quality is good. Check your dependencies for known vulnerabilities. Use taint analysis to catch all these kind of injection flaws and similar security vulnerabilities. And make sure that static analysis, and specifically static analysis checking for security, is part of your development workflow and your process. Here's a quick overview of the tools that I mentioned, if you want to make a picture of this, if you haven't already during the other slides. Oh, by the way, the slides I will post online later, so don't worry about it. And if you want to find me online, then here you can find me. Thank you very much.